Well, hello and welcome back to the radio room. As you can see on screen there, we got some things tore apart on the Wavetek function generator, or pulse function generator. Model 145, if you're wondering. It's not terrible to take this thing apart. Things do get a little... It's just being held together by wires basically right now. There is the nice thing about this is in the service manual, it literally tells you how to take this thing apart in order to do diagnosing and repairs. What wires to unhook, what you might have to rehook in order to do your diagnostics. As you can tell, there's some wires that just they're just on like little bullet type connectors. Quite a few of them. I think there's one wire you have to unsolder to get the board out. Well, so I got it tore apart. Didn't take me too long. More of a exercise in trying to hold things and pull things out the board, support the board. You nearly need 3 hands, but we got it done anyhow. So I went ahead and did a little bit of diagnostics on this, and I just wanted to do some quick checks on some things before I actually went in there and started doing anything on screen. So I'm going to pull up a schematic here. Hopefully this works, because I might not have it set up quite right. It did. So this is the output amplifier, and in the previous video, remember, we kind of went through the troubleshooting path, and it said check the final amplifier, output amplifier. And I was kind of suspecting from the beginning that it might have had something to do with the amplifier or some stage of amplification, because we were basically, the bottom half of our waveform was very distorted. So in the output amplifier, as you can see here, let me find it. Well, as you can see, basically looking at this really is the whole, get this out of the way, output amplifier. So this is where it comes out. It's got the output attenuator, which is right after it. So basically this does what it's going to do, with a little bit of variation on depending on what waveform you have and what frequency. I'm sure it changes just a little bit. And this right here would be each one of the attenuation positions that you have on the output attenuator. The vernier that we were adjusting before is right here. This controls the output of the output amplifier. And then whatever is coming out there, once you have it in full, you can get an accurate attenuation and function out right there, of course. So as you can see here, this is a whole lot of, now this little box right here and this little box right here are not on the board. It's a whole lot of mostly resistors and transistors. It's got a couple of capacitors here and there. I did a visual inspection of the board, didn't see anything fried or burnt. So that kind of led me to being probably the most likely culprit would be one of the transistors. And I did basically a quick and dirty check on those right on the board, and I'll show you kind of how I did that real quick if I can get the camera set up. This kind of a cluttered workbench right now. Let me get back over to where we're at here and see if I can whoops, that's not the one I wanted, but that one will actually work. So you can actually see the bottom of the board right here, up in your upper right hand corner of your screen. Let me see if I can get this set up right. So just kind of how I did this. Get this so you guys can see it. I'm going to go to diode check. Hopefully y'all can see that. Right now it shows infinite. If I were to touch these together, it goes to 0 volts drop across whatever I'm measuring. Typically a transistor is going to have somewhere in the vicinity of, say, depending on the type of transistor, what sort of semiconductor material they're using, Let's say like germanium or something like that, you're going to have, about 0.3 volts all the way up to, say, normally 0.8 to 0.85 volt drop, depending on what kind of the transistor it is. So basically what I did was, I just want to do a quick and dirty check on the transistors. Now, the easiest way to do that is obviously in circuit. That does not always give you an accurate reading, but it can help you narrow down something that might be obvious. So I'm going to go ahead and go over to, and I might have to move this real quick, but you're going to be able to see this a little bit better if I do it this way. So I will, I'm just going to get this out of the way for a moment. First thing you got to do is find the transistors. I know I'm jumping back and forth here, but you guys want to see this. So, see if I can do this. Like I said, this thing's just kind of hanging out here. We got some transistors right here that are on, they basically got big heat sinks on them. I'm going to lay this down here really carefully. So we got two transistors here. They got big heat sink fins on them. Then there's two more right here. These two silver guys. And then underneath this heat sink, and they actually have little heat sink cups on them. I've removed this one, and I'll show you why here in a minute. They go up here to this heat sink right here. Basically, this is transferring the heat from that transistor to this big piece of aluminum. So you want to find those, but there's no good way to do any testing from here because they're so close to the board. So what I do is, and I've shown this trick before, is on some of these boards, you're sitting there looking at it and you got a lot of solder points on this side of the board. And sometimes you can kind of look and tell that where a transistor is. I mean, you can kind of do okay, let's look at this side of the board. Let's come over here. Okay, so I know this is one of the transistors right here. Mostly because I know the pattern, the footprint of how that transistor is sitting. So it's quite likely I have three connections right here. That's a transistor, which in this case it is. But when you start getting over here, sometimes it gets a little harder to see them. It's where a flashlight comes in handy. On a lot of these boards, they're translucent enough that you can see the light through the board. Let's see if I can get this to set up a little bit better here. Might get rid of a little bit more light, but you can see through that board quite well. So if I go straight over a transistor, if you look right there, you see a big blob. And I'm not sure if you guys can really see it. I'll see if I can turn it here a little bit. You can actually see the fins. So right in the middle of that, I know these three right here are that transistor. And the same thing down here. You can actually see this one a little bit better. There's the fins. There's the 3 points from the transistor. I move over a little bit further, and I can see the round body of there, and there's the three contacts. And right down here, now you got to be kind of straight on. There's another transistor right there. Now these are big can type transistors. They're a little bit older type style. So if you're looking for smaller ones that are present in today's equipment, you're going to be looking for a different shape or less of a blob of dark. So what I did was, I'm going to see if I can set this up so you guys can see it. See if I can turn this. Like I said, everything's just kind of hanging on by a thread and getting ready to really fall apart on me. Maybe y'all can see that. Yeah, it's not too much glare, hopefully. And like I said, I'm in the diode check. So I'm going to go to one of my transistors. So let's try this one right here. Now, these might be PNP, they might be NPN. It doesn't really matter right now, because what I'm going to do is I'm going to go to 2 connections. Okay, I got something that exceeds the normal voltage drop on a transistor on that one. We go to this one. Okay, that's infinite. So I know from here to here, we're good. That's showing an initial reading with an infinite after it, so I'm going to guess there's probably a capacitor in that circuit, part of that circuit. If I go this way, I get a normal transistor voltage drop. If I go between these two, just a capacitor. Basically what I'm checking here is make sure nothing's shorted. So I just kind of do every combination of contacts with that and make sure everything looks good. So I'll go down to the other one. Goes right there and kind of do the same thing. Yep, got a pretty good reading there. That one might be a capacitor with... Okay, I turn it the other way and now I'm getting a normal voltage drop across basically a diode that's inside the transistor. And I'm not finding anything that's shorted in this one. So let's see, let's go over to, gotta find it again. Just did those. Did that one and that one. Ah, these right here. That looks normal. That's not something I wouldn't not expect. Let's go this way. And some of these you might reverse them. So see, like here I got a good reading. Let me reverse those two with the probes. I got infinite. Now you might still get a reading if there's resistors involved between those 2 pins, but that's a normal reverse bias for that transistor. Same thing there. And in these two, that's probably collector and emitter or emitter and collector, so I'm not expecting to see anything there. It looks like there's probably a capacitor involved. Come down to my other one. That one's good. Let me try it backwards. Good. Good. Looks pretty good. Yep, got that direction here. And backwards. So those look good. So then I moved outwards to this side of the board. Went to these other transistors. Now I'll show you this one right here. Let's see here, right here. That looks good. That looks good. That looks good. And that's a little low, but it could have some resistance in it. Now, I've already pulled the transistor out that is in this other location. And it's this one right here. It's got a little standoff it goes through that keeps it off the board. And I'm just going to check this one. This is basically, I'm going to show you the reading as soon as I find it. Find out which one it was. That made me start wondering, hey, there might be something wrong with this one. And there it is right there. That is extremely low. 0.018 volt drop. Now I seen that in circuit, and I went back to the schematic and said, well, is there anything that would be pretty much nearly a dead short as far as resistors in the schematic? And we can look at that. This is Q45, I believe. Yes, Q45. So let's go ahead and go back and take a look at that real quick. And right there is Q45. I was going between the base and the emitter, I believe. Or was it the... Okay, I think it was the base and the collector is what I'm measuring between on those two. So between this point here and this point here, when it's in circuit, remind you, I was checking this with it in circuit when that reading caught my eye. So how are these connected together? Well, let's see here. If I go from here, I come back, come over, I come to a transistor, which I'm working on this thing off. This should be off. I shouldn't have any current flow there. So, and remind you, I'm just looking at this as a quick and dirty check right here. So what if I was maybe on the emitter? It's not like they're labeled on the board. First off, this way, there's no way I'm going to have that lower resistance. That would be from here to here. There's just no way to get that lower resistance. So what if I'm going from here to here? I don't know what pins I'm on. Let's find out. From here, we go up here. Okay, we got two 15s in parallel. I was like, yeah, that might be the deal right there, because that's only going to be 7.5 ohms between these two. But in order to get there, I still have to go through a 100 ohm resistor, and I still have to go through a 61.9 ohm resistor that are in series with those. I should be looking at a resistance, and the way my meter works, you can nearly judge your resistance by your voltage drop because of the voltage it's using to test. So it basically comes out to like 18 ohms in order to have that reading of voltage drop. So I should have a reading of somewhere between 100, let's call it 170. That's a whole lot more than what I had. So I suspected this transistor is shorted out. And sure enough, when I test it out of circuit, as I just showed, it's basically a short. So that made me think, okay. And that's the last amplifiers on the output of the output amplifier. So it's quite likely that would be the reason why we're losing half of our amplification, and it changes as we try to amplify more. Basically because the drive is being shorted out on that side, and the more you drive it, the more you see that. So I decided, well, I'll pull that out and test it out of circuit like I just did, and that does not test like a good transistor. I should be on these. It looks like the voltage drop between either the base and the collector or the base and the emitter should be right around 0.8 volts or 800 millivolts. It's a bad transistor. So then became the hunt. This is I'm sure y'all are going to be able to read this thing. It's a little hard to read. It's a Motorola 2N5160, which in a little research I've done is quite popular in this vintage of function generators as an amplifier. Several other companies use the same one in their final amplifier design. Well, they don't make these anymore. So I did finally find some. They're actually on eBay. Came out of China, so I'm keeping my fingers crossed. But a nice new bright shiny one that does say 2N5160 on it. So I'm hoping that's what's actually in there. It does have an M on it. Looks like the Motorola symbol. Maybe. Let's hope it's not fake. But we're going to put that in there. And we're going to see if this thing works again. So I'll get this thing... first off, I got to do a couple things here. For one, this standoff's got to come off of this one. It just slides off. And straighten some legs out on this a little bit so I can get it started. And you just put it through those slots right there. And push it down to the bottom. And then that's got to slide through the holes there, which might be a little bit more of an adventure. And then we'll get this thing soldered in. Now, it does have a heatsink cap on it. Basically just slides over the top of it. I am going to clean out all the old thermal compound in there. I'll just use some isopropyl alcohol and probably a Q-tip or something. Might let it soak a little bit. As far as it's a little dry, but it's still got, I mean, you can see it still sticks to my finger and spreads. So it's not like it was totally dried up, but I'll have to get that done real quick before I can put this back together. I can actually solder this in and then put the cap back on it when I get it in there. So let's see if I can actually get this thing through the holes. The nice thing about it, if you can see the pattern here, it's pretty easy to tell which way it goes. I mean, it basically sits in there just like the transistor legs are. So, you know, they point this way, so to speak. So I just got to get that lined back up like that. Keep the same orientation. And get it through the holes all at the same time. And then I'm going to just bend the legs just slightly, because it's got to make sure it stays flush up against the board. This right here goes on the top, and then that screw part goes into the bottom of this in this slot. So the spacing is critical there. See, this is mounted to the board. Okay, so hopefully this is going to work. I really hope it does. I'm a little leery sometimes of getting electronics from places on eBay from China. Don't always know exactly what you're getting. We're hoping it meets the exact same standards. It said new old stock, which means this could be a, you know, say 25, 30-year-old transistor. It's never been used. Should still be good. But we'll see if it either works or the whole dang thing blows up in our face after we get done and get it all put back together. So we get this soldered back in, and then I'll probably cut the video and we'll come back after I've cleaned up the cap and probably get this thing reassembled. It's going to take a little bit of time to get it put back together, but we'll turn it on together after we're done. Okay, and that's as simple as that. We'll cut these legs off before we put it all back together. Let me re-tin my soldering iron here a little bit. Keep that tip to last a little longer. And turn the temperature down because I don't anticipate using it for a few moments. Find my clippers. I'm just going to cut those excess legs off. Now, like I said, I didn't see anything that looked like some cooked resistors or popped caps or anything like that. So I'm just kind of going with the idea that they're probably still in good shape. Doesn't mean just because something doesn't look bad that it's not. You know, a resistor could have changed value or something like that. But I'm really thinking that this transistor just failed because over time it got hot and it went, shorted itself out. So I'm hoping that's the truth. But I'm going to go ahead and pause the video here, and I'm going to get this cleaned up and see if I can put this thing back together, and then we'll turn it on and see if it actually works. Or, well, let's see if it hopefully works, because there's alternatives that, if that ain't right, could make a difference. But I'm going to go ahead and trust that it's good for the moment, and hopefully everything is good, and we have a beautiful signal generated with a nice perfect triangle wave or square wave or sine wave. So I'll be back with that here in just a few moments. Okay, we're back. I've got this thing pretty much put back together. It's still a little wobbly. The outside case is what really gives it structure. There's slots these slide into. So, got it put back together. We've got that transistor changed. So hopefully the bottom half of our waveforms looks like the top half. So I think it's time to, I'll make sure this thing's going to work. So I think step one is let's go ahead and just turn it on. I've got it plugged in to the wall. And, well, let's turn it on. Make sure it doesn't start spewing smoke out or anything. So I'm just going to hit the power button. Okay, we do have the light coming on right here. I don't know if y'all could see that when it came on. So far so good. Don't smell anything. Don't sense anything that's getting real hot where we just changed those. So I think the next step is going to be plugging it in and seeing if it's got any sort of waveform on it. So there's the top. So as soon as it's on, I'm going to plug in the coax to the function out, and let's watch the I don't have the knobs on the front of this thing. I don't know where anything's really set. Hopefully it's on continuous, which I think is where I left it. So, and I might be on the 1K scale because I think I centered some of the dials before I took the knobs off. When I put the knobs back on, I'll just figure out where they're at and line them up correctly. Or put the knob on, turn it to the, say the left stop, and hook it up from there. So let's see what it does when I hook it up. Oh, well, we got something on the screen, don't we? So let's take a look at this a little closer here. Okay, it looks like a triangle wave. Pretty good. Maybe got just a little bit of something going on with it. No, it actually looks pretty good. Let me, that looks like a pretty good triangle wave. My knob, my frequency knob on the generator is sitting about the 1, and I think I left it at 1K. So let's see if we can go to frequency. Yep. And so it's at 1.029 kilohertz. I'll bring it a little bit closer to 1. Okay, that's got me pretty much right dead lined up on the 1 on the dial. And 1.007 kilohertz. I'm going to call that close. That could be off just off the deal. Let's make sure we get plenty of frequency swing. Okay. Now, if you'll remember from the last video, that bottom there showed a lot more. See, it's got a little bit of rounded right there. I wonder if that's just something we can get rid of in the alignment. Let's go to, well, first off, I'm going to make sure. I'm going to check okay, so this is the attenuation, the vernier attenuation. And it works pretty smooth. And this is, remember before we had a problem when it was all the way up. And it should be on 0 attenuation. So, Let's see what a sine wave looks like. That's a pretty nice looking sine wave. Some of this thing's probably going to have to be realigned, especially after doing the work on it. The square waves look a little weird. Let me see if frequency has anything to do with this. You can get higher in frequency, they look a little bit better, but you can see it does have a little bit of a rounded right there. It's a pretty sharp cutoff, or actually that'd be on. The going to negative seems like it, so it could have a little bit of a balance problem. But I think that's something we can maybe be adjusted in the alignment. But they actually look kind of like what they're supposed to look like. You know, triangle wave, sine wave, and they look kind of like square waves. I mean, let's see if we can find a different frequency. So this should be, yeah, it's 1.1 megahertz, which actually I'm saying right at 1.1 megahertz. There's pretty much 1 megahertz. Oh, it's dead on. So I think we definitely have success. Let me do one thing here. Okay, I'm a little bit low. Let me get that perfectly centered. And we're doing a pretty good job. Let me if you look at the let me bring this. So right there, we're right between those two radicals. Let me pull the bottom over, and right between those two radicals. So it is fairly balanced as far as positives and negatives. And that is a lot better looking. And that's full output. So yes, I think that fixed it. I think it might need an alignment. Maybe tweak a few things. I'll probably go through that process sometime and get it a little bit better, especially on that was it triangle wave looked a little off. Yeah, triangle wave looks a little bit off, and that might be within specifications of this. I'm not sure. Square waves look like they could use a little bit of help. See if the attenuation is working. Yep, there's 20 dB down. Yeah, it starts looking a little bit better. Oh, well, I wonder if part of that's just my... Let's try something else here. Well, that actually looks really nice. I think I got stuff dirty on my oscilloscope. Is causing some of that problem. Yeah, because see, in there, not sure you can see the flashes. But you get up into, well, now it's just, I think that's an oscilloscope problem. You know, I'm going to change channels and see what the other channel looks like. That's not actually looking too bad right there. Let me do one thing here. That's actually not looking too bad. Once I get my oscilloscope to cooperate with this, see, I can jiggle. I'm jiggling the deal there, and it looks bad there, and then I jiggle the vertical here. I think I got dirty contacts. There we go. And vary the frequency. Oh, I think the generator's doing just fine. Let me step it up to, I'm not sure my oscilloscope's gonna, okay, that should be, yeah, it kind of turns more into a sine wave when you get up to, 16.9. Kind of starts turning back into a square wave when you lower the frequency. So that might be something I'm gonna have to look into. I think maybe it can't switch that fast. Both sides look fairly, and it's got a little bit of a bump there in the top. Of course, this is on a square wave. Let's triangle wave doesn't look too bad. Sine wave doesn't look too bad. I think I'm about as fast as my oscilloscope will go. So that should be 20 megahertz, roughly. It's not off too far. I'm going to call this a win. Let me go back down to the 1K. Slow this thing down so we can see it. Most of the time I think I would be using sine wave anyhow instead of triangle wave. So I think we're going to do pretty good. This, I could get this thing up there about, this thing is pretty touchy. Let's see if I can use the vernier to adjust it. Yeah, right in there, I might be doing some IFs or something. And that looks like a fairly clean signal. So I'm going to call this a win. So basically, it's a good generator. Might need an alignment. But just had some output amplifier problems. That one transistor that had failed. And was really messing up the waveform. So Wavetek Model 145 is back into the living. Thanks for stopping by the radio room, and we will see you next time.